Hi, welcome to AB Video 4.5B and C, more on integration by substitution. Okay, so we're doing the same thing. Remember, we let u equal the contents of the parentheses. If there's two parentheses like here, you're going to let u be the one with the highest degree. Makes sense because the derivative of an x squared would give 2x, right? Okay, so we let u equal the x squared minus 9. Right away we figure out the du. It's 2x dx. Well, isn't that nice? We have everything we need. So we have u cubed du. Integrate that, we get u to the 4th over 4. And feel free to go directly from here to here. You can tell it's going to be u to the 4th over 4, and then replace u by the x squared minus 9. Don't forget the plus c. Okay, here's another example. Again, the contents of this radical is a quadratic, but this over here is a linear. So we're going to let u equal the quadratic of 1 minus 2x squared, the contents of, not the entire radical, because the derivative of that would be very ugly. So our du is 0 minus 4x dx, and sure enough, we have everything we need. So we have u to the 1/3 du. We integrate. We would get u to the 4/3 over 4/3, which is times 3/4 plus c. But of course, you cannot leave your answer in terms of u. You replace u by 1 minus 2x squared. So another example, obviously we're going to let u equal the contents of the parentheses, which is x cubed plus 5, and the derivative of that will be 3x squared dx. So it turns out that we have the x squared dx. The only thing we're missing is the 3. Introduce the 3, counteract with a third, write it in terms of u if that helps you. So it's 1/3 integral u to the 4th du, which is 1/3 u to the 5th over 5 plus c, and of course u is x cubed plus 5, and then I'm just simplifying. 3 times 5 is 15. Here's another one. Again, this one is a degree 4, that one's a degree 3, so we'll let u equal the contents of the parentheses in the denominator. The derivative of 1 plus x to the 4th is 4x cubed dx. So as you can see, we have the x cubed dx. All we need to do is introduce a 4, counteract with a quarter. And of course, if you need to, you can write it as 1/4 u to the negative 2. Notice I brought this up and made the exponent negative, which would be 1/4 u to the negative 1 over negative 1, which would be negative 4 over u, and then replace the u by 1 plus x to the 4th. And yet another one. And he's thrown these in on purpose in the book, and that is, this one cannot be done by substitution, because if you let u equal the contents of the parentheses, which is t, because the square root is kind of like t in parentheses to the half, the derivative of that is 1 dt when you got all this extra stuff. If you think, oh, let me let u equal the numerator, well, then the problem is that the derivative of that is 1 plus 4t, and we don't have that. So substitution fails. We're going to have to do it the old way. Remember, there's no quotient rule, so we're going to have to split it up. So t over t to the half plus 2t squared over t to the half. 1 minus a half is a half. 2 minus a half is 1/2. And now we're ready to integrate, etc., etc. You can take it from there. Here's another one. Again, substitution won't work, because if you let u equal the contents of the parentheses, the derivative of that u would be negative 3/2 y to the half, and we don't have any y to the half. So we're going to have to do it the old way, which is we're going to pull out the constant 2y. We're going to distribute, because remember there's no product rule, and then we're going to differentiate from there, which should be easy for you to do. To that. Okay, so just a review of strategies for integration by substitution. What you're going to let u equal, the contents of the parentheses or radical. The denominator, that's going to yield an ln. For example, integral 1 over u du equals ln absolute value of u. The exponent, you'll see the variable in the exponent. That's usually integral e to the u, integral a to the u. If it's trig, the angle or a whole trig function. Okay, once you've got your u, don't forget, find your du immediately. Do not delay. Okay, so this is a differential equation. They want you to solve the differential equation, which means find the function y equals f of x that has this derivative. So remember, the first thing we do is separate the variables, bring all the x's to one side, all the y's to the other. Then we integrate. In this particular case, this will give y. You'll let u equal the contents of the parentheses. The derivative of that is 2x minus 8. And as it turns out, 2x minus 8, we have x minus 4, and 2x minus 8 is 2 times x minus 4 dx. So all we need to do is introduce the 2, counteract with a half. When you integrate your u to the negative a half, you'll get u to the half over a half, which is times 2 over 1. The 2's are gone, and there's your answer. Trig functions, again, this is just a whole lot of review. Remember with trig, you either let u equal the angle or the trig function. In this particular case, you'll let it equal the angle. You know you won't let it equal the whole trig function, because if you did that, the derivative of that would be cosine, and you don't have a cosine. So you let u equal the angle. The derivative of that is 4x cubed dx, and that's exactly what we have. We don't need to introduce anything. We have integral sine u du, which is negative cos u, which is negative cosine x to the 4th, plus c. Okay, over here you have a choice. What we're going to do is go with the contents of the radical, which of course works out very nicely, because if we let u equal tan x, du is secant squared x dx, which is exactly what we have. So you're looking at the integral of u to the half du, which is u to the 3 halves, over 3 halves, which is times 2/3. Don't forget to turn the u back into what it is in terms of x. Again, we could either let u equal the denominator, the contents of the parentheses. In this case, we're going to look at this as cosine x to the 3rd, and we're going to let u equal the contents of the parentheses. The derivative will be negative sine x dx. We've got sine x dx. We just need to introduce the negative. I don't know why I didn't put a little arrow there. We introduce the negative, and we counteract with a negative. So we're now integrating negative integral u cubed du, u to the negative 3 du, sorry, which is negative u to the negative 2 over negative 2, which is positive 1/2, and then the u squared can go down, and don't forget to change the u back into cosine. So your answer is 1 over 2 cosine squared x plus c. There is another option. Remember what we started with, sine over cosine cubed. You could get creative and change that to sine over cos times 1 over cos squared, which happens to be tan squared times secant squared. And of course, if you let u equal tan squared, your du is secant squared x dx. You get u squared over 2, which is tan squared x over 2. So then the problem becomes, oh, look at how different these two look. In effect, though, they are the same, because 1 over cosine squared is secant squared, okay? And then you could replace secant squared by 1 plus tan squared, break it up, and of course 1/2 plus c1 is just another constant c. That can sometimes take more time than going back to square one and trying it another way. Cosine 6x dx, super easy. Of course, you're going to let u equal the angle, which is 6x. The derivative is 6 dx. Introduce the 6, counteract with 1/6, etc.,